Hello students, today I am going to explain the last part of the chapter Force and Laws of Motion. The last part of the chapter includes Law of Conservation of Momentum. So let us start today's explanation with a recap of the definition of momentum. As we have learned earlier, momentum is the product of mass and velocity. So, momentum depends on two factors. One, how much stuff is moving, that is mass, and how fast the stuff is moving, that is velocity. Momentum is denoted by small p, that is equal to m into v, that is mass into velocity. The unit of mass is kg and that of velocity is meter per second. So, the unit of momentum is kg meter per second. Now, let us move on to conservation of momentum. Conservation of momentum means that the total momentum of two bodies will remain constant before and after collision. You can see a diagram in front of you. While listening to the explanation, do keep your books open and see the diagram. You will have a much clearer idea when you see the diagram while listening to the explanation. Let us take two balls A and B moving with velocities UA and UB. Their masses are MA and MB. They are moving in the same direction, and if we consider UA to be greater than UB, then they will collide with one another. Here we can see the collision. If we consider that the collision lasts for a time t, then the ball A will exert a force FAB on the ball B, and the ball B will exert a force of FBA on the ball. Let us take that VA and VB be the velocities of the two balls after collision. Here we can see VA and VB. After seeing the change of velocities of both the bodies after collision, now we are going to find out their total momentum before and after collision. In order to do so, first we have to find FAB and FBA. FAB is considered as action and FBA is considered as reaction. In order to find FAB, we need to find the momentum of body A before collision, that is MAUA, and its momentum after collision, that is MAVA. So we find FAB to be MAVA minus UA by T by the definition of force, that is rate of change of momentum. Similarly, we can find FBA, that is MB into VB minus UB by T. After that, we will write FAB equal to minus FBA. This is in accordance with the third law of motion, which tells us that action and reaction must be equal and opposite to each other. Now we have the values of FAB and FBA. If we put the values in the equation, we are going to get this, and by simplifying this, we are going to get MAUA plus MBUB equal to MAVA plus MBVB. This gives us the equation of conservation of momentum. From this, we can see the total momentum of the two bodies before collision is equal to the total momentum of the two bodies after collision. So, we can say that the momentum of a system of bodies is conserved, means that they will remain equal before and after collision. So, we have reached to the end of today's discussion and the explanation of the chapter as well. Hope the earlier videos and today's one helps you in understanding the chapter properly. Both in-text and exercise questions are provided in school website. Download them and go through them. Next week, I will be back again with the explanation of a new chapter. Until then, take care.